All right, so we're going to talk about graphing quadratic functions. And quadratic functions graph as the name of their graph is called a parabola. P-A-R-A-B-O-L-A-S. So parabolas, no matter what form the quadratic function is in, it's going to have the same shape. Okay, we're going to talk about different forms today. We're going to talk about standard form, vertex form, and intercept form. Those three forms are what we're going to talk about today. But no matter which form the equation is in or the function is in, the shape is the same. It's still a parabola. And a parabola looks like this. Or that. It can open up or it can open down. Okay? All right, so parabolas can open up or open down. No matter what form they're in, that decision of whether they open up or open down is decided by A. If A is greater than 0, what kind of number is it? Hey, we're just getting started, man. If A is greater than 0, what kind of number is it? Positive. If A is a positive number, then opens up. Yeah, sure. If A is less than 0, what kind of number is it? Negative. Okay. If A is positive, it's going to open up. That's this way, up. If A is negative, it's going to open down. That's this way. Okay. All right. No matter what form. So we're going to start with standard form because that's the one that kind of requires probably the most amount of work. Standard form and intercept form are both about the same amount of work, but vertex form is a little less work. So we're going to finish off with it. So let's start with standard form. Standard form for a quadratic function, f of x, remember that's just the same thing as y. That's y equals ax squared plus bx plus c. Same old standard form we dealt with in quadratic formula. That's standard form for a quadratic function. Okay. There are some things we're going to find when we're graphing a quadratic. The first thing we're going to find is what's called an axis of symmetry. An axis of symmetry for a quadratic is this. It's kind of an imaginary line, but we're going to draw it with a dotted line when we graph them by hand. It's a line that goes right down the center of the parabola, and you can if you can pick up the paper and fold it, and you folded it right along that axis of symmetry, each side of the parabola would match up. It's like a mirror reflection of each side there. So the axis of symmetry, it has an equation. If we're dealing with standard form, that equation is going to be x equals negative b divided by 2a. Negative b divided by 2a. X equals negative b divided by 2a. It is an equation, so I need x equals, and then this will turn into a number. Okay, that's what we're going to see when we do an example of this. Okay, that axis of symmetry, what it looks like for a parabola, you've got the parabola shape. The axis of symmetry is this dotted line that goes right down the middle. That's what it's going to look like when we graph it by hand. Okay, we're going to do an example of that in just a little bit. All right. The second thing we're going to find is the vertex. The vertex is an ordered pair. Here's the great thing about finding the axis of symmetry. You get the x value of the vertex for free. All right. The vertex on the graph, axis of symmetry goes right here. The vertex is this point right here at the bottom. Yes, sir.
Okay. Is this like that graphing thing we did earlier where there's going to be a difference between solid lines and dotted lines?
No.
It's gonna be dotted lines?
No, it's not inequalities or what you're talking about. That's not what this is. The vertex is this point either at the bottom or if A were negative and it opened up, it's at the top. Okay, so those are and the X value is the same as the axis of symmetry. The Y value for the vertex comes from plugging in that number into the equation and working it out. Okay. Axis of symmetry, X equals negative B over 2A. Vertex, the X value is negative B over 2A. The Y value is when you plug that number into the equation and work it out. You're going to get a Y value back. And it's an ordered pair, X, Y. Okay. Now, we're also going to find the X intercepts. X intercepts are set AX squared plus BX plus C equal to 0 and solve. Whether you solve that by factoring or quadratic formula, either way, okay? There might be some cases where you might be able to solve it by square roots if there's not a BX in the middle. Solving it by square roots could be an option, okay? So X intercepts, we're just going to set the equation equal to 0 and solve it. That's going to be for no matter what form we've got. Quadratic form, we get the option of quadratic formula or factoring are good options for solving something when it's in standard form. Okay. Fourth thing, the Y-intercept. Plug a 0 in for X. No matter what equation we deal with, when we get to higher degree polynomials next week, we're going to be talking about finding the Y-intercept of those. No matter what kind of function you're dealing with, to find the Y-intercept, put a 0 in for X and you got it. If I plug a 0 in for X here on a standard form problem, what happens here? 0 squared is 0. 0 times A, still 0. B times 0 is 0. 0 plus 0, 0. Then plus C, our Y-intercept, if it's in standard form, is always going to be at C. So it's got this ordered pair, 0, C, if it's in standard form. What I want you to remember is not that it's 0C, but that you just plug 0 in for X. Because if it's in a different form, it's the same rule. And plugging the 0 in makes it pretty easy in standard form. All right. All right. Last thing we'll make is a table. And that's, and we'll get this with an example in just a second. Okay. I'm going to show you how you can make a good table based on what your vertex is and make your graph look nice. All right. So let's look at an example of a problem that's in standard form. All right, here's our example. F of X equals X squared plus 6X plus 9. X squared plus 6X plus 9. So we're going to find all 5 of those things first, and then we're going to graph it with the graphic calculator. May use the graphic calculator to help us find our table too. I'm going to show you how to do that as well. So that'll save us a little step. So the first thing we're going to find every time is our axis of symmetry. What's the formula for axis of symmetry? Negative B over 2A. So negative B would be negative 6 over 2 times what's A? 1. Negative b over 2a, so that's negative 6 over 2, which turns into negative 3, right? X equals negative 3. That's our axis of symmetry. All right. Since we know our axis of symmetry is x equals negative 3, what do we know about the x value of the vertex? It's automatically going to be negative 3. Always. Axis of symmetry, x value vertex, always going to match. Okay? Always. All right? How do we find the y value? You plug that number in for x. Plug that number in for x. Work it out. So that's going to be 9 minus 18 plus 9. 9 minus 18, negative 9 plus 9 would be 0. So we get this ordered pair that the vertex is negative 3, 0. All right. Now, because we got numbers now, we can talk about whether that's a maximum or a minimum. Okay. The way we decide that is we decide which way does it open. Which way does it open, up or down? And how do we tell? What was the rule of the third line we wrote? It said if A is greater than 0, it opens up. If A is less than 0, it opens down. Well, what's A in this one? Positive 1. Is that greater than 0 or less than 0? Greater, so it's going to open up. Okay? So if we know it opens up, that means that this vertex is a minimum. The reason it's a minimum is when something opens up, it looks like this. The lowest value on the graph is down here at the bottom. That's what opening up means. That means this vertex is a minimum. It's right down here at the bottom. We'll see that when we actually graph this thing. Okay? So a minimum is when it opens up. Well, you know if it opens up, if A is positive, it opens up. If A is negative, it's going to open down. Okay, that's the way you're going to know that. All right. So now we have axis of symmetry. We have the vertex. The next thing we're going to find would be our X and Y intercepts. Let's do the hard part and find the X intercepts. All right, so how do we find the X intercepts of a quadratic? Solve it by setting it equal to what? 0. So we have x squared plus 6x plus 9 equals 0. What do we want to do to solve that? We can do the x method factoring. This one will factor. So if we do that, multiply to be 9, add to be 6. That's 3 and 3. I can take my shortcut on the factors. And then I'm setting each of those equal to 0. Turns out this one has the same answer twice. So that means there's only one x-intercept. That x-intercept is at the point negative 3, 0. Where have we seen that already? That was the vertex. If it only has one x-intercept, that x-intercept is going to be the vertex. Usually we will have two x-intercepts where it crosses the x-axis twice. That's normally what happens. If we were to do this with quadratic formula, what would we know about the discriminant of that one? The b squared minus 4ac. And b equals 0. Very good. Tying all this stuff is not random. It all ties together. Okay? So the more you can tie it together, the more weapons you have to try to defeat this stuff. So we found the x-intercepts. Turns out there was only one. It was at -3, 0, which happened to be the same as our vertex. That's not always what's going to happen. Okay, you're gonna find those x-intercepts the same ways though. All right. Next thing is the y-intercept. A little bit easier to do here. I like the y-intercepts because it's just plug a 0 in for x. 0 squared plus 6 times 0 plus 9. Well, that's 0 plus 0 plus 9. So we have a y-intercept at 0, positive 9. Just by plugging a 0 in for x and cranking out the number. Nothing really fancy about that at all. It's never going to be fancy finding a y-intercept. X-intercepts, yeah, that's a little more fancy. A little more work to do that. Y-intercepts are always going to be that easy. So we have an ordered pair at at 0, 9. We have a vertex at -3, 0. That happens to be our x-intercept. And then we need to make a table. Here's how I try to make my table every time. Put the vertex in the middle. That'll get you a good picture of what's going on really easily. The vertex was -3, 0, so I'm going to put that in the middle. We'll put the vertex in the middle. And then I'm just going to pick some x values that are to the left of it and some x values that are to the right of it. So to the left of -3, that's going this direction. What are some x values that would be there? -4, -5. And then to the right of that, I could use -2 and -1. Here's where the graphing calculator comes in. I'm not going to ask you to, plug in those numbers in for x, just like we did the 0. That's what's happening. That's what we're really doing. I'm going to show you how you can use the graphing calculator to help you do that. Okay. So with the graphing calculator, everybody get that out. I'll show you how you can get it to help you with the table. This is a handy thing for this, and it's also going to be a skill we really need when we get to higher degree polynomials. We need this. Okay, so all right. This is what I need everybody to do. I need you to hit second and then the window button. So the second one in the top row. And you should get the table set up. Second window. Get you to table set up. Yours may not look like this. We're going to fix everybody's the same before we start. All right. This is how I want your thing to be set up. I don't care what the table starts. That doesn't matter. Delta table, that means how much your table, if you let it automatically generate one, that's how much it changes by every time. It doesn't matter what's there. The only thing that matters is that you have the independent variable set to ask. So go down there to independent, move over to where ask is blinking, and hit enter. Make sure that the dependent is on automatic. Okay? Independent on ask, dependent on automatic. The independent is X, the dependent is Y. Okay? Doesn't matter what numbers are here, just that this is ask and this is auto. Everybody set that way? If you're set that way, then the next thing's going to make a lot of sense. All right. Now hit Y equals to get here. Just hit the Y equals button. And now let's type in the equation. We had x squared plus 6x plus 9. The button right beside the green alpha button, that's if you hit that, that's going to give you an x. The squared is right above log. And get the rest of it you got. All right. Now, we want to go to the table so that we can get those ordered pairs to make that table with. So the way you do that is hit second graph. And you should be here. And you may have some numbers already typed in here that your calculator had stored. You may not. If you've got numbers there, it's okay. We're going to type over them anyway. Okay. Here's where we're going to copy the x values from that table we just wrote down. -5, -4, -3, -2, -1. Those are the x values that I'm going to type. -5, enter. -4, enter. -3, enter. -2, enter. -1, enter. It cranks out the y value. As long as you typed in the equation the right way, it cranks out the y value that goes with those. Notice we got 4, 1, 0, 1, 4. That's a symmetric table. The table's not always symmetric. If your vertex is a decimal or a fraction, then sometimes it gets off a little bit. But ours is whole number here.
So how do you remove all the,
Once you x squared. Second graph. Now you're going to type in those values, -5, -4.
you get rid of all the numbers below that?
Don't worry about it. All right, yeah, yours ended up in clear. Oh, yeah. All right, x squared. X squared plus 6x. There you go. All right, so now they've got the next one. Anybody else have issues, calculator issues? All right, so we got the table now. We got 4, 1, 0, 1, 4. What you could do if you had to graph this by hand is then go plot these points on the coordinate plane. Okay, so if you do that, and I'm going to do that, so I find myself a little ruler here. We're going to graph it on the calculator too, but I want to show you graphing one by hand as well. So I'm going to draw myself a coordinate plane. I'm going to make sure it's tall enough to get that Y-intercept on it. I think that is maybe. I'm going to plot those points. I'd go to -5, 5, and 4, -4 and 1, -3 and 0. And then I had that Y-intercept was 0, 9, right? So I'm going to plot that point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gets me a good idea of what's going on. There's my parabola. This is what the axis of symmetry looks like. It's this dotted line that goes right through the middle. So if you're asked to graph the axis of symmetry and the quadratic, or just asked to graph the axis of symmetry, it's going to be this vertical line that goes right through the middle of the vertex. If your axis of symmetry doesn't go through the vertex, something went wrong. In one direction or the other, something went wrong. Okay, so there's a lot of checking spots here. Notice we have our X Intercepts graphed here. That -3, 0 was the only one we had. It happened to be the vertex. Not always going to be that way, but it happened to be on this one. And then it's opening up. That's the right direction. And then we have some other ordered pairs there. We got our Y-intercept up here out of that. That's what the graph's going to look like. Now, if you graph it on the graphing calculator, I've got the equation typed in here. Make sure that your stat plots are off. So if one of these, plot 1, plot 2, plot 3, is darkened in on your calculator, and you need to arrow up until you get to that where it's blinking. Like if yours looks like that, then you need to turn that off by going up there and hitting enter, and it'll turn that off. It's going to cause issues with some of your graphs if you have that on. Okay. We hit graph, and there we have my picture. If your graph doesn't look like that one, hit zoom 6 to get back. Zoom 6 always will get you back to the default 10 by 10 window. That's what zoom 6 does on the graphic calculator. We see that picture. It does not graph the axis of symmetry on it. You would have to put that in as a separate equation. We're looking to see if our graph looked right, and ours did. It looks something like that. A little better curve there for them.
How do you graph it? Because I'm taking like the X and Y equals.
If I take it right. All right. Right. Down that one. You won't have to do this. Now that you've done that, you won't have to put that down in the graph. You won't have to do that stat line. Okay. All right. So there's one in standard form. Let's look at the next form. Vertex form. Right, let's do intercept form next. That one takes a little more work. So intercept. Intercept form takes a little bit more work. Intercept form looks like this. A parentheses x minus m, x minus n. Last week, we called that what form? What did it look like we were doing to solve it? If it looks like this, the parentheses stuff. Looks like they've already done what to it? They've already factored it, right? Intercept form and factored form are the same things, okay? The reason they call that intercept form is because all you've got to do to find the x-intercepts is do what with each set of parentheses? Set it equals 0 and solve it. So they call it intercept form because it's so close to getting the x-intercepts. Okay. Now, out of that A that's in front is the same A that was in front of the standard form. Nothing different. Okay. That A still decides if it opens up or opens down, and that decides whether we have a maximum or a minimum on our vertex. Okay. So A still decides everything. All right. So we're going to still find those things. All right, so let's look at an example of this. This will be example B. Let's call it f of x equals negative, and then x plus 5, x minus 3. Okay. Negative, then x plus 5 and x minus 3. Still going to do the axis of symmetry. It still has the same formula. The problem is that we don't have A, and we got A, but we don't have B. So what we've got to do is multiply this thing out to get B to use. Okay, so distributive property happening twice here, or 3 times actually. 1, 2. So that'd be x squared minus 3x plus 5x minus 15. And then we have the negative that we need to distribute as well. That's negative x squared. Negative 3 plus 5 would be positive 2. Then put the negative on it, so negative 2x plus 15. Once we're there, we're back to standard form. Okay, so we've taken an intercept form and moved it into standard form so that we can find the vertex and the axis of symmetry. Okay, so we're working toward that. All right, that's why I wanted to do this one right after the standard form. All right, so now we can take negative b divided by 2a. So negative b is going to be positive 2 divided by 2 times negative 1, which would be 2 divided by negative 2, which is negative 1. So we have this axis of symmetry at x equals negative 1. What do we know about the x value of the vertex? It's negative 1. Locked in already because that's what the axis of symmetry was. Okay, always going to match. How do we find the y value? No, not for the vertex. We put it negative 1 in for x because that's the x value of the vertex. So we're going to find the vertex, we got to plug in the x value of that. So we're going to plug in negative 1. If you do all the math right here, it doesn't matter if you plug into this blue one right here or the original. I'm kind of the persuasion that I think it's better to go back to the original and plug in there. That way, if you made a mistake, hopefully you'll catch it here. Okay, so I'm going to go back to the original and plug into it. So negative 1 plus 5 is negative 4, or I mean positive 4. And then negative 1 minus 3 is negative 4. We multiply all this together. So positive 4 times negative 4 is negative 16. And then times a negative 1, technically, would be positive 16. If I plug that into the one where I'd work that out, I should get the same answer. That'd be negative 1 plus, did I do that right? 3, not 3 plus 2. So that'd be 17 minus 1 is 16. Same answer. Okay, no matter which one I use because I did the math right there. But I tend to always go back to the original if I'm plugging a number in. That way, if I made a mistake, I'll hopefully catch it. So we now have the vertex. Now we need to decide, is that a maximum or minimum? So we need to know which direction does this parabola open. Does it open up or open down, and why? It's based on A. A is negative, so this one's going to open down, which would mean that vertex is going to be at the top. Which means it's a maximum. That's going to be important, especially when we start doing some word problems this week. Maximums and minimums and stuff like that. Those are always important parts of word problems. Maximums and mins. Okay. All right. What's next? X intercepts. This thing is in intercept form, so that makes this part easier because it's already factored for you, right? If it's in intercept form, then all you got to do is take negative x plus 5 and x minus 3 and set it equal to 0. What does that mean we do? What can I do with each factor that has a variable? I technically can divide by negative 1 here and get rid of it. And then I get x plus 5 and x minus 3 still equal to 0. Then I set each of those factors equal to 0. It's already factored for me. I don't have to do that hard work. Okay? Nobody signed up? Did anybody want breakfast? All right. Thanks. That's okay. All right. Now, when I solve those, I get my X intercepts. This one's got two different ones. It's got x equals -5, x equals +3. We want the ordered pairs for those. -5, 0, and 3, 0. Those are the ordered pairs for the x-intercepts. That means this graph, remember it opens down, it's going to come down from the vertex at -1, +16. It's going to come down from there, and it's going to hit the x-axis at -5 and at +3. That's what's going to happen to this graph. Okay? What's next? Y-intercept. Y-intercept for intercept form, still not that hard. It's still just plug a 0 in for x. 0 plus 5, 0 minus 3. That's going to be negative, and then 5 and -3. 5 times -3 is -15 times a -1. So it's going to cross the x-axis, the y-axis at 0, 15. It's going to cross the x-axis at -5 and +3. Right. Table. Last thing is a table. And a lot of times the table is where you get a lot of checking happening. What goes in the middle of the table? Vertex. Our vertex was -1, 16. So I'm going to go left to -1. So that'd be -2, -3, 0, and 1 to the right. I'm just picking the next values, easy integers next to it. Okay. Go to y equals. Type in the original problem. Negative parentheses x plus 5. Close those parentheses. Another set of parentheses, x minus 3. Okay. Y equals, go in there. Now I want to build my table. How do I do that? Second graph. I've got some values typed in there already. It doesn't matter. I'm just going to type over the top of them. -2, -3, -2, -1, 0, and 1. I just need those 5. If I've got more of them, it doesn't matter. Okay. Look. Turns out I get to check a couple of my points that I found when I was working. My vertex at -1, 16. I got that right. I had a y-intercept at where? 0, 15, right? 0, 15. Hey, that's the right point. Okay. So I've got a couple of points that I could check there. All right. If I wanted to check my x-intercepts, what x values would I type in? Okay.
I don't know what to do. I don't know how to do it.
It doesn't matter. Just type it.
It will let me type over. So it's going to do that every time?
It should.
So then I go, oh, okay, so that, thank you.
Yeah. It's a little extra something. Graph there. So, still looking for what x value should I try to check?
And then now, if it's your window, you get graph and I'll put some.
Anybody else? So what X value should I plug in to check? Zoom 6. Anytime you get that error, hit zoom 6 and it usually fixes. What are the X intercepts? It's supposed to be -5 and 3. Hey, I can check those right there too. That's handy. All right. Now, I've got my table 12, 15, 16, 15, 12. So I've got that table. I could plot those points on a coordinate plane. I could also hit graph. Is everybody seeing a graph that looks something like that?
All right. Did you go back to the plot as the plot place of the
There, where I'm getting the points.
There's the points.
Okay.
The y equals 1. The y1.
Right here.
Yes.
So we got a negative sign, x plus 5 in parentheses, and then make sure your calculator has a negative sign and then a minus sign. It doesn't read them the same way. So if you get an error, go back and check any of your negatives or minuses. Here we're dealing with a negative. Here we're dealing with a minus sign. They're two different ones. So if you get an error or something goofy happening when you graph something and it doesn't look like what it's supposed to, then you probably need to go back and check those signs. All right. Notice I can't see my vertex or my Y-intercept here. How could I get my graph to show me those?
If you use my calculator, you can do it on.
All right, so if I want to move my window a little bit, there are a couple of options. If I want to be able to see the whole thing, zoom, and then number 3 is zoom out. And what it does is wherever your cursor's at, it's going to zoom out from that point. So it's like on Google Maps, when you zoom out, if you scroll backwards on Google Maps, it scrolls back from whatever point your mouse is at. So whatever your cursor's at, if you hit enter, it's going to zoom out from there. And you can see it there. And you don't get an option about how much it zooms out. It just zooms out. Okay. Another option, if I'm here at back to the original, if I hit window, I can set the actual numbers of how far it goes. Okay. So if I know my Y-intercept is at 16, I know I want my Y max to be bigger than that. So if I went down there to Y max and changed that to 18, and then my X max and Y, they don't need to change. I just need to get the graph taller. If I do that, now I can see the whole thing. And if I want to go back to the regular normal window, how do I do that? Zoom 6 goes back to the 10 by 10. Zoom 6 is always going to give you 10 by 10. You can adjust it if you need to out of that. That's handy knowledge to have. You should be able to plot those points from that table and make a graph by hand if you needed to. We know the axis of symmetry is going to be that dotted line, goes right down the middle of it. So that shouldn't be an an issue. Let's look at the last form, and that's vertex form. I like vertex form. It's fun. Vertex form. F of x equals a parentheses x minus h squared plus k. If it's in vertex form, it's called vertex form because they give you the vertex. That's a handy thing. Because if we have the vertex, then we know we have the axis of symmetry for free. Those go together, right? The x value for the vertex is the same as the axis of symmetry. Always. Here's how it works. A, same A we've been dealing with the whole time. Okay? It decides up or down, max or min. Same A. X minus h in parentheses with the squared. That value that's in there, if it's a +3, we're going to take a negative out of it. We're going to do the opposite of whatever's in parentheses. We're going to do the opposite of that. Just like you would if you were finding intercepts, when you set those factors. Okay? The plus k, we're going to take whatever that is. So if it's, bless you again. All right, so if it's +7, we're going to take +7. If it's -5, we're going to take a -5. Okay? So opposite on the inside, same on the outside. Okay? We're going to look at an example of that. Great thing about vertex form is it's already got the vertex for you. You don't have to do the formula. You don't have to do anything. No work to get the vertex or axis of symmetry. It's there for you. Okay? It also has a nice way of getting the X intercepts that you don't have to do quadratic formula or factoring, or it's not as nice as intercept form is, but it's still pretty nice. Okay, so let's look at an example. Let's say we had f of x is equal to 2 parentheses x minus 3 squared plus 5. There we have vertex form for a quadratic parabola. We're still going to find the same things. Axis of symmetry. I'm getting tired of writing that, so I'm going to abbreviate. And then we're going to find the vertex. And I'm not leaving much room here because we don't have to do any work. Okay? I'm going to get the vertex first because it's in vertex form. I recognize this as being vertex form. So you need to be able to recognize what form you have and build from it. Okay? So now I know that that's vertex form because I see the parentheses with the squared. That's how you're going to know it's vertex form. Okay? So the vertex, negative or x minus h plus k. Okay? That vertex is going to be at 3, 5. We're going to take the opposite of the inside. That's a -3. We're going to pull a +3. Take the same as the outside. That's a +5. We're going to take a +5. Okay? We get the vertex for free. Okay? I don't know if y'all go to the supermarket with your mom or dad or grandmother or whatever, but it's like bacon day at the supermarket. It's free. Giving out samples of bacon. That's a great day at the grocery store. Bacon is awesome, unless you're a vegetarian. And maybe they're giving away vegan bacon. I don't know what that's made out of, but maybe they're giving that away. So it's a great day when you don't have to do any work to get something. Because we got the vertex, we now know that the axis of symmetry matches which part of that? The x value. Because axis of symmetry is x equals, right? 3. We got 2 of the 5 things we're looking for without doing anything. Is Napoleon Dynamite, let's say? That is awesome. I love it when that happens because now I got to do some work, but I didn't have to do any to get that. I just had to be semi-smart. What's next? X intercepts. Okay. This is actually, there's a shorter way. Okay. Here's what we got to do. We set the whole problem equal to what? 0. So we set 2 parentheses x minus 3 squared plus 5 equal to 0. Okay. Then we do what? Solve it. This one is a great candidate for solving by square roots because I can get the squared part by itself. There were a few problems that were on your test Friday that were quick to solve by square roots. If you did it by quadratic formula, it took a while. But if you did it by square roots, it was fast. So I would subtract 5. And then divide by 2. Here's where we're going to run into a problem. The squared part's by itself. The next step is to do what? Take the square roots. Plus or minus on the side with the number. What kind of number is underneath the square root there? Negative. That means we're going to have what kind of solutions? 2 complex solutions. Complex solutions do not cross the x-axis. So graphically, when we graph this thing, it's not going to touch the x-axis at all. So there are no x-intercepts. None. Technically, I'm going to put the I in the front because it looks better. We could get the complex solutions out of this by just, getting that by itself. 3 plus or minus I. But for our purposes in graphing, which is what we're focused on this whole time today, we know that because that's complex, then we don't cross the x-axis. So your answer about x-intercepts, there aren't any. Okay? We know they're complex because we're smarter than that. We've already solved some. Okay? You okay, Dan? You need to take care of it. It's okay. All right. Now let's get the y-intercept. Y-intercept, what do we plug in? 4x. 2 parentheses 0 minus 3 squared plus 5. Let's work that out. So 2 times 3, negative 3 squared plus 5, so that'd be 2 times 18, or 2 times 9, which is 18, plus 5, 23. 0, 23. There's our y-intercept. Last thing we want to make up is our table. What goes in the center of your table? And my vertex for this one was 3, 5. So I'm going to go to the left of 3, 2 and 1, to the right of 3, 5, 4 and 5 for my x values. Crank out those. Use a calculator to help you. If you get some that have a fraction or a decimal in the vertex, then use decimals. I mean, it's okay to get decimals in your answers here with that. So I'm going to y equals. I'm going to type in my equation. 2 parentheses x minus 3. Close the parentheses, and then I'm going to hit the squared button. Make sure you're not in the exponent world. If you are, press the right arrow key and then plus 5. Second table. And I need 1, 2, 3, 4, and 5. I'm also going to check 0 to make sure I got that number right. So there I have my table, 13, 7, 5, 7, 13. And then I checked my y-intercept to make sure I got it right. That's what that 0 is for. Forgot the numbers already. 13, 7, there's my table. You should be able to plot those points on a graph if you needed to. I'm fine with, there's my parabola. Doesn't cross the x-axis.
Can you go into the table, please?
Yeah, sure. Second, okay. The first 5 are the only ones that I'm really concerned about. I just checked 0 to make sure I had my y-intercept right, that I did the math correct. Any x value you want to check, you can type in with that table and get there. There's a good bit of stuff to do on this. Every problem's got 4 or 5 things on it. Now, when you go to Khan Academy, they're going to be kind of asking for one of those things or 2 of those things out of that. They're not going to ask for all of those things at once. Okay. Quiz purposes, you're going to have same idea. You're going to have most of them are asking for one piece, and you might have one problem that asks for all of it to put it all together. Okay. So be able to pull out certain and use only certain pieces when you need it. But to find the vertex, you've got to find axis of symmetry anyway, unless you're in vertex form. That's the only time that you won't have to do that. Okay. It takes a little practice. So I've assigned some things in Khan Academy for you to start working on. So we're going to take, you got about 20 minutes left today, and you'll have tomorrow. It's actually about 15 minutes left today, and tomorrow to work on that stuff. And again, if you missed the test Friday, we're going to take that tomorrow and try to get going with that. So